Hello, ladies and gentlemen. Let's do transformations of nonlinear data. First of all, let's take a look at some possible curved data. Okay, here are some pictures of different types of curves and the way that we can transform them. To help cope with the variety of ways data can be nonlinear, there is a variety of functions we might try to fit to our data as we attempt to describe or explain the relationship between the variables. Some examples of elementary functions, together with the associated transformations of variables leading to linearity, are collected below. All right, so this first one that we see is the exponential. Now, this does not just involve exponential growth, it can also involve exponential decay. So we can also use this if the line is curving down. So what we're going to end up doing to transform the data is we're going to take the log of y. So that's exponential. So if the dots have a curve, either curving down or curving up like that, that is a possibility. The next one is also logarithmic, or taking the log, but this one is only taking the log of x, and you can see that this line curves in that fashion. So if the dots kind of look like that, then we're going to go ahead and try that. The third one is quadratic, okay, the parabola. Okay, there is no transformation for that, or at least there's not one that we're going to do. The next one is the reciprocal. So again, you can see the line is curving down like this. So if the dots form that type of pattern, we might want to try the reciprocal. We've also have the square root. Okay, if the dots kind of look like that, we could try taking the square root of x. And then we've got one that fits pretty much everything, okay, the power. That's where we are going to take the log of x and the log of y. And you can see there's all kinds of different patterns that will fit the power. So we're going to have to try more than one transformation, but at least this breaks it down a bit for us, and we're not having to try a ton of different things. Now, a few things I do want to point out to you. Remember, we have logs. Now, this log is base 10, okay? Log base 10, and that's for the rest of them too. This is log base 10, and these down here are also base 10. So we're not doing any strange bases, so base 10. Also, instead of taking the log of something, okay, you could do the natural log. So like in this case, it would be the natural log of y. It's going to get you the exact same results. It's just the numbers are going to be a little bit different, but you're going to get the exact same answer. So you don't have to check both of them. If you prefer using natural log, you can use natural log. Same thing here. We could use natural log for x instead of log x. Down here, we could do natural log of x and the natural log of y. And that'll give us the same results. We'll get different numbers, but in the end, we're going to get the same results. All right, so on this page, remember our mathematical description. If the data is already linear, this is the equation that we use, y hat equals a plus bx. If we transform the numbers using the square root of x, then our equation becomes y hat equals a plus b times the square root of x, because we took the square root of x. Down here, the log of x. So you can see we've got the base 10 in there. So y hat equals a plus b log base 10. Again, you don't need to put the 10 on there. The calculator is already in base 10. And then we can also use natural log, like I said on that other page. Y hat equals a plus b natural log x. If we do the reciprocal, then the transformed line will be y hat equals a plus b times 1 over x. And then down here, we're going to have to do a little bit of work to figure out what the equation is. Because remember what our goal is, folks. Our goal is to be able to graph the dots and then type an equation into our y equals and have that line go through the dots, which I will demonstrate as we go further through the lesson. All right, so we need to refresh ourselves a bit with transforming these equations. So let's start with the first one. All right, log y. So we've got log, I'm going to put a hat on that, y hat equals a plus bx. Now, in order to graph it on the calculator, we're going to have to get y by itself. We can't leave it as log y. And remember, since it's base 10, we can use 10 to help get rid of it. Think back to advanced algebra, solving equations. Okay, it might have been a while since you've done that, but we solved equations with logarithms in advanced algebra. And one of the things we had to do is get rid of the word log. Okay, so we have to use the inverse. Okay, and the inverse to get rid of log is 10. So, and remember, the basic equations you started learning when you started learning algebra is what you do to one side of an equation, you do to the other side of the equation. All right, so what we're going to do is we're going to rewrite this as base 10 to the log y hat, and then the other side, base 10 to the a plus bx. And again, the reason we did that is so that we can get rid of the word log. So what are we left with? Using our laws of exponents, or not laws of exponents, but laws of logarithms, or rules for logarithms, they cancel out, and we're left with y hat equals 10 to the power of a plus bx. All right, so that's when we take the log of only the y. Now, if we do natural log, so natural log y hat equals a plus bx. To get rid of the natural log, remember, it's e, okay, Euler, or Euler, depending upon how you say it. So we say e to the ln y hat equals e to the a plus bx. So, again, this cancels out, and we're left with y hat equals e to the a plus bx. So, it'll be our job to find a and find b so that we can use one of these equations and we can type it into our calculator so that we can see the line go through the dots. All right, let's look at the other one. So in this case, we're taking the log of x and we're taking the log of y, and that's the power property. So when I write this out, I have log y hat equals a plus b log x. Now again, I have to get the y by itself. So I'm going to follow the same rules, except there's a little bit more work to this. So I'm going to rewrite this as 10 log to the log y hat equals 10 to the a plus b log x. Well, just like on the first page, this is going to cancel and we're left with y hat equals. Okay, but there's a little bit of work we need to do on the right side. First of all, we need to remember that when there's something in front of the word log, it doesn't stay there. We rewrite that, and whatever's in front of the word log becomes the exponent. So that becomes log x to the b power. All right. So I'm going to skip another step in here, and I'm going to rewrite this right side like this. I'm going to go 10 to the a power. Now, the rules for logarithms, okay, is this. And rules for exponents. This goes way back to when you started learning rules of exponents. Okay, this is now a times 10. Now, this is going to be written like that. So log x to the b power. And just like on the left side, the 10 and the log cancel each other out, and we're left with y hat equals 10 to the a power times x to the b power. That is the power property. X must be a base. All right, so again, it'll be our job to find A and B so that we can type it into the calculator. All right, so basically, ladies and gentlemen, memorize, okay, memorize. From here to here. Same thing on this one. Okay, from here, whoops, not there, hold on. From here to here, memorize. All right, let's look at, so this was log on both x and on y. So real quick, think about this. So if we did the natural log of x and the natural log of y, so that would be natural log of y hat equals a plus b natural log of x. Okay, well, think about this, ladies and gentlemen. It's going to look almost identical, except the 10 is going to be replaced with e, and the rest is the same. All right, so again, ladies and gentlemen, just memorize that. You're not going to have to show how you get it from one to the other. And again, we're going to want to find A and B. All right, so here we go. So let's go to this. All right. So the age, we've got a relationship between the two variables. And this one is dealing with the prices of Ford Mustangs and how old they are. So we're going to put L1 in, or age in L1, all of the ages, and then put all of the prices in L2. Because this is the explanatory variable, this is the response variable. All right, you may need to pause the video to do that. I already have that done. Okay, so if you're going to pause, now would be a good time to pause. All right, so I've already got the numbers typed in. So list 1, list 2. Now, before you go any further, you want to back up the data in L4 and L5. Truthfully, you can back them up in any list you want as long as you remember. I picked L4 and L5. So what you want to do is you want to go over to L4, go to the very top, and then do second number 1. What that's going to do is that's going to dump the numbers from list 1 in L4. That way you have all of the ages of those cars backed up. Same thing, L5, go to the very top, and let's dump the prices in L5 as our backup. So we're going to go second, L2, because that's where we typed them. So we now have a backup of our data because we're going to need that. All right. So first thing we're going to do is we're going to take a look at the picture. So we need to make sure our stat plot is on. Yep, our stat plot is on. Everything looks good. L1, L2. All right, zoom 9, and here's the data. And it is very obvious that it is not linear. All right. So we're going to go ahead and do the original equation in this spot. So we're not going to transform it yet. So we're going to find our A, find our B, find our R, and then we're going to write the equation and take a look at it. All right, so we need to go stat, calculate, number 8. Make sure it says L1, L2. And here we go. All right, so here are the numbers that we need. So let's fill this in. All right. So A is 10,351.85. And we're going to go 2 decimal places because it's money. B is negative 619.78. R is negative 0.729. Now, something you need to remember. Correlation only is used for linear data. That's why we have to transform this data. You can only use R on linear data. Only on linear data. All right, so our equation is y hat equals 10,351.85 minus 619.78x. All right, let's just take a look at that. Let's go ahead and type that into our y equals 10,351.85 minus 619.78x. Graph. Okay, again, you can definitely see we've got that curved pattern going. The linear line is not the best. All right, now what are we going to do? Well, this is where we want to look at our picture. So it's curving down. Well, if we look at the paper, this paper here, go back to our picture, or our pictures, it looks like we're going to try this one because it's curving down. So it's a potential exponential. So we got to go through the process and look at all of the information. All right. So the first thing we're going to do is we have to take the log of y. So let's go back to our paper. So we're going to leave x alone, but we're going to take the log of y. All right, so on our calculator, let's go ahead and delete our equation. We don't need that in there anymore. And then let's go stat edit. So we're going to take the log of y. So that's list 2. So in list 2, we're going to go log of list 2. So you have to tell it list 2. Again, second number 2. And if you mess up, remember you've got your data backed up in list 5. All right, so there's the log of list 2. Now let's look at zoom 9. Well, it's definitely straighter. Okay, it definitely looks more linear. All right, so what we need to now do is stat, calculate number 8, because we're going to need that information. All right. So in our table, we're going to go ahead and write down our A, B, and R value. Here we go. So our A value is 4.08, and our B value is negative 0.055. And our R value is negative -0.768. Okay, it's definitely stronger than the original. Now, looking at this paper here, okay, let me go back. Okay, let me go back to this. All right, so we're going to rewrite it like that so that we can type this into our calculator. All right, here we go. So we're going to write y hat equals 10 to the power of 4.08 plus negative 0.055x. Close it. Now, if you use an old calculator, you must use parentheses. Old calculators, you have to use parentheses when you do that. Okay, so now go back to your calculator. But the first thing we have to do, ladies and gentlemen, is we have to put the original data back in list 2. So we're going to go back to the top, and again, we backed it up for this reason. So you're going to go second, list 5, and dump the original numbers back in. So when you do the zoom 9, we've got the original curve. All right, now let's type in the equation. Again, this is why we got to get y by itself so that we can type this in. So we've got 10 to the power. Now again, those of you with old calculators, you must use parentheses. Those of you with the new fancy calculators, you don't have to. 0.08, 4.08 plus or minus negative 0.055, okay, minus 0.055 or plus negative 0.055x. And then again, those of you with the old calculators, you must close it. All right, graph. Isn't that a thing of beauty? Okay, it looks okay. It might be, it's off a bit because we rounded. Okay, but we notice that here on the left side, that might not be the best. All right. Now, the next thing we want to do is we want to look at the residual plot. All right. Now, when we did the stat calculate number 8, remember, it automatically found the residuals for us. Now, I'm going to show you a different way of doing this. We do not need to dump the residuals in list 3. You can if you want. But what I'm going to do is I'm going to go up here. I'm going to go here. And I'm going to go down to my Y list. And what I'm going to do now, okay, once I'm on L2, I'm then going to go ahead and hit second stat, which is your list. And I'm just going to put the word resid in there, okay? You do not have to dump the residuals in list 3 to do this. So I'm going to look at the residual plot, okay? First, I'm going to go ahead and take out the equation because I don't want to see that. And then I'm going to go ahead and do the zoom 9 again. Oh, that is not a good residual plot. There is a definite pattern there. Okay, so, taking the log of y is not that good. We've got a pattern, and our correlation is negative 0.768. All right, the next one that we want to look at that's curving down is the reciprocal. So that means we're going to take each x value and we're going to take 1 and divide it by that. All right, so back to our calculator. Okay, before I do anything though, I'm going to go back here and I'm going to change my Y list back to L2. All right, now I'm going to go stat edit. I'm going to go to L1 now because I'm going to transform the L1 numbers. So I'm going to take 1 and divide it by L1. There we go. All right, now we're going to do zoom 9. Now this is going to look a little weird. Whoa, it completely changed it. Instead of going down, they're going up, but that's okay. because we're going to go back to the original stuff after we've transformed the equation. All right, so now we're going to go ahead and do the stat calculate number 8. All right, so let's see. We've got A as negative 1791.11. We've got B as 49001.90, and R is 0.896. So that's definitely better. All right, so let's fill that in on the table. So we took 1 divided by x, log, nope, not log, just we left y alone here. We back that up. All right, the A value is negative 1791.11. Again, I'm going 2 decimal places because it's money. The B value is 49,001.90. And the R value is 0.896. Now remember, it's the number that tells us the strength. The sign only tells us the direction. Okay, so it is stronger because it's 0.896. It's almost 0.9. All right, so we're going to write our equation now. So y hat equals. All right, so let's go back here a second and let's take a look. So it's this one right here. So we're going to write that as negative 1791.11 plus, I'm going to write it as 49,001.90 over x. Okay, we don't need to, we can just replace the 1 with that. And you don't need parentheses, but it makes it a little bit nicer. All right, back to the calculator. So now we're going to go back to our stat plot. Nope, not yet. So we're going to go to our edit. We need to change it back to the original. So again, you dump the original in list 4. So we're going to put the originals back. There we go. So now when we do the zoom 9 again, there we go. It's all back to normal. Now we're going to type this equation in. So we're going to type in negative 1791.11 plus 49,001.90 divided by x. Graph. Oh, that looks so much nicer. Notice how the dots are pretty much throughout the whole line. That looks way better. This might be the winner, folks. This might be the winner. All right. So that looks really good. So what we want to do now is we want to go ahead and look at the residual plot. So remember, all we need to do is go back to our stat plot, go down to our Y list and put the residuals there because the calculator found the new residual plot after we did the stat calculate number 8. All right, so go second stat for your list, go to resid, put that in that spot. Let's delete the equation because we don't need it at this time. And then we're going to go zoom 9. Oh, that's definitely better. It's not the best, but it's definitely better than the other residual plot. That's much better. Okay, so that is a good residual plot. Not the best, but good. Okay, I'm going to go back here. This residual plot was bad. This residual plot is better. We could even say good. All right, so I think that's the winner, but we're going to try one more. Okay, the other curved line that we want to look at is with the power, this one. So we're going to take the log of x and the log of y because we can see we've got a curved line right here that it kind of matches. All right, here we go. So I'm going to go back to my stat plot, and I'm going to put this back to normal first. So I'm going to put L2 back in my Y list. Okay, I'm going to go to my stat edit. All right, so I'm going to go to the top now, and I'm going to take the log of list 1. There we go. Boom. And I'm going to go to the top of list 2, and I'm going to take the log of list 2. Boom. All right, zoom 9 that. Hey, that doesn't look too bad. That straightened it out pretty good. This might give the last one a run for the bunny here. All right, here we go. So now we want to do the stat. Calculate number 8, because we need to find our A, B, and R values. And there they are. All right, let's fill that in on the table. So we took the log of X and the log of Y. So what did we found? We found A to be 4.69. Double check that. Yep. And we found B to be negative 1.20. And the R value, let's double check that. Okay, the R value is negative 0.829. Cool. All right, now I'm going to go back here and I'm going to go back to my work, this one right here. All right, so this is what we want. All right, so let's write that equation out. So we're going to say y hat equals 10 to the 4.69 power times x to the negative 1.20, or just negative 1.2. All right, let's type that in and take a look at it. But first, remember, we need to go back to, whoops, not that button. We need to go back to our original data. So we need to go in and dump list 4 back in. Again, this is why we do the backup. And dump list 2, or list 5 back in list 2. There's our original data. Zoom 9. Okay, good. All right, let's type this equation in. So now we have, let's see, we've got 10 to the power of 4.69. Okay, make sure those of you with new calculators, hit your right arrow key to bring it back down. And then x to the negative 1.2 power. All right, let's see. Hey, that's not too bad either. Okay, that's pretty good. Let's look at the residual plot. So again, we're going to go back here and we're going to dump the residuals in the Y list. Nope, I didn't do zoom 9 and I got to erase my equation. Let me get rid of that. And let's do zoom 9. Well, that's not too bad either. So that matches the last one we did, the reciprocal. So we're going to have to go based not necessarily on the residual plot, because that's not too bad either, okay? Not bad for the residual plot, okay? You can sketch the residual plots below if you want to, so you can see them a little bit better. So the residual plot is almost the same. So I think we're going to have to pick, though, the reciprocal. We're going to have to pick this one. Okay, that is the winner. It doesn't pay to try anything else because there's nothing else that follows those patterns. All right, so again, down here, you can sketch your residual plots if you want to go back and do that. Just know how to read a residual plot. Remember, we don't want any patterns and we want it scattered throughout. All right, let's look at the next page. So based on the residual plot and the correlation, what can we conclude? Okay, we're going to conclude that the reciprocal is the best. So we're going to use the equation y hat equals negative 1,791.11 plus 49,001, whoops, let me make that a 1, 0.11 over x. So I'm going to make these predictions for 10 years, 15 years, and 20 years. Okay, but I'm not going to plug the numbers in. I'm going to use my y equals screen. You can certainly plug in 10. You could plug in the 10 down here if you want. Plug the 10 in, plug the 15 in, plug the 20 in. Okay, but I'm going to go ahead and use my calculator and go to my y equals. I'm going to retype that in. 1791.11 plus 49,001. Oops, I forgot a 0, I think. No, I didn't. 49001.90 divided by x. And I'm just going to go to my table. Okay, well, my table's way off, so I'm going to go ahead and I'm going to jump back to 10. So to jump, you go second window, and then type in your number that you want to jump to, and then go back to the table. All right, so there's my prediction for 10 years. $3,109.10. $3,109.10. Okay, 15 years. Oh, it's on the screen. $1,475.70. $1,475.70. Okay, 20 years. Again, 20 years is pushing it. We're kind of getting out of the range of values if you look at all of those numbers. But we'll go ahead and look at what it is. Okay, so we're going to go to 20 years. $658.99. $658.99. Now remember, don't forget about extrapolation. All right, remember that is predicting beyond the data. And you'll notice that that would happen. If I keep going, eventually I'm going to run into negative numbers, and that's just not possible, okay? The lowest value, they're not going to pay you for the car, or they're not going to pay you to keep the car, or I don't know how you think of it, but you're not going to get a negative there. Okay, no, this is it. You're not going to pay them to take the car. Okay, you're going to give them the car and you're going to give them cash? I don't think so. So the lowest value here would be $0. But that's going beyond the data, because if you look, ladies and gentlemen, at the original data, it goes from 4 to 18 years. And predicting much beyond 18 would be a bad thing. All right? Okay, so I'm going to go ahead and talk about this one a little bit. So in this problem, we do not want to use the 19 for any of the years. You can just not type those in. So on our calculator, we just need to put the last 2 digits of each of the years. You certainly could type the whole year if you want, but you don't need to. And then in list 2, we're going to put the other numbers, the rate. So what is this problem dealing with? The rate of infant deaths for both sexes per 1,000 live births each year in the United States is given in the following table. All right, so you're going to want to go through the same process as we did on the last one. So you're going to type the numbers into your calculator, which I have done. You're going to want to look at the picture. Oh, I've got a dimension mismatch, so let me go and see if I can fix this quick. So let me double check my years. Okay, this should only take me a minute. Okay, oh, I bet I know what it is. I bet I did not. Yep, I did not switch my stat plot back to list 2. So I had all the numbers right, but I did not switch that back to list 2. Okay, so now looking at the graph, ladies and gentlemen, hey, that's pretty close to the last 2 problems or the last problem we just did. It's curving down. So that means, first, remember, do the original. I want that filled in. Then you're going to try the exponential. So you're going to do the log of y. Then you're going to want to do the reciprocal. So 1 over x, y. And you're going to want to do the log x log y. Okay, so go through each of those and figure out which one is the best. Again, you can sketch the residual plots at the bottom if you need to. Look at your R value. Okay, look at the residual plot. Pick out the one that is best so that we can use that equation to make predictions. And then do the same thing with this one. The vehicle miles traveled per mile of road and the rate of motor vehicle accident deaths per 100,000 population for 3 areas of the United States: West, South Central, West Mountain, and West Pacific, and given in the following table. So go through that same process. Okay, and this is the only assignment you need to do for chapter 4.1 because I took that book assignment off. All right. Later.